Support for today's Heat Treat Radio episode is provided by Heat Treat Bootcamp. Find out how to enroll in this basic training at www.heattreattoday.com/bootcamp. And welcome to Heat Treat Radio, a podcast from Heat Treat Today. Whether you're listening to us or tuning in via video on heattreattoday.com/radio, we're glad to have you. If you're looking for tips on solving overtemp or water flow alarm issues in your vacuum furnace, this interview with SECO Vacuum's Don Marteeny and Caleb Johnson will provide this and more. Host Doug Glenn, the publisher of Heat Treat Today, will also be asking them some rapid-fire round questions in the second half of the interview. Stay tuned.
On your screen is Don Marteeny. Don is from SECO Vacuum Technologies and is the VP of Engineering. Don's got a lot of experience in this industry, so his input will be valuable. And also on the screen is Caleb Johnson, who is the Field Service Manager, also for SECO Vacuum Technology. So gentlemen, thanks a lot. Appreciate you joining us, okay?
Yep. Thanks, Doug. It's a pleasure.
Yeah, great. We're just going to jump right in, okay? I'm just going to ask questions, and you guys can go back and forth, decide who wants to answer these. I won't call on any of you specifically. You can just decide. But we're talking about top vacuum furnace maintenance concerns, all right? Typically, if anything, probably the most dire one is, dang it, I can't get this doggone vacuum furnace down to the vacuum levels that I want. Where do we go? What do we do?
Yeah, so that's probably one of the more critical ones on a vacuum furnace because there's a lot of issues that would stem off that. But I'd say one of the first checks I would look at is the vacuum gauge itself. You know, does the trending look okay? Do we think the gauge is still functioning properly? What's your scaling look like? And because those are electronic items, they do have a life on them. So it's an easy one to rule out right off the bat. The next one would be your vacuum pumps. Are they functioning okay? You know, has the oil been changed recently? Is oil okay? Is the pump still working good? You know, just going through some of the basic checks like that and see, you know, is functionality wise, are we good with everything? Mm-hmm.
Is it typical that the vacuum gauge will fail slowly over time? I mean, can you see a degradation of it over time so it starts getting off target, or is it just kind of like, well, this thing just is boom, gone?
On our furnaces, they usually fail high, so it'll just say it's at atmosphere even though you're under vacuum. But also the low level on the vacuum gauge will start, it won't reach as good a vacuum, you know, so maybe the furnace is there but the gauge doesn't register that, and so the gauge itself just starts drifting. So yeah, either way are both common.
Okay. All right. So valve, they get the gauge first and then the pump. Was there anything else?
For the pump, I think you could look at the amp draw on it, make sure the motor's still functioning properly. That's a big one.
Okay. Yep. Don, you were going to jump in?
Yeah, I was going to say one other thing that I've seen commonly too is, you know, if a customer is running a process that may, you know, in some way present some contamination to the furnace, say. Usually one of the questions that I ask after those is, how long has it been since you did a cleaning cycle, right? You know, by that I mean, you know, about 100 degrees over the process temperature for eight hours just to basically bake everything out of the insulation, right? Or moreover, was the furnace open over the weekend? You know, did somebody accidentally leave it open, got thinking, didn't pump it back down, and there's moisture? Okay, I would expect the first run there to be problems reaching vacuum, right? We've got to, you know, and there's an easy answer to that. Yeah, you might not get through the production that day, but you know, you've got to put it through a cleaning cycle first. Let it run overnight and start back in the morning and see where we are. And furthermore, that can also apply to the gauge. You know, as we were talking, sometimes it's not necessarily the gauge has failed, but there is some contamination. You know, there are ways to prevent that, like the installation of what we call a clarifier, which is basically a tube, copper tube that allows anything that might be in the environment to condense before it reaches the vacuum gauge. You know, there are several remedies for these common issues, but you know, we have to go through the list basically when this comes up.
Right.
And I'd say too that cleaning cycle then gives us a baseline, because all our vacuum leak checks are specified in a clean, dry, empty furnace. So after a burnout, you try and get rid of all that contamination. Door hasn't been opened yet. That's the best time to do a leak up check and say, is any air getting into the furnace? So a lot of times you'll also see on your load, if you have discoloration, even in the furnace itself, if you're getting air or moisture in there, you're going to get some blue or green colors that kind of allude to that. Now, if the load's off gassing, maybe that's a common color that you're getting.
Right.
But specifically, if you're getting air in the furnace, you may see the discoloration. The leak check would show that. A lot of times we're specified at 10 microns an hour. Now, over time, the furnaces might not meet that spec. And as you get further and further from that spec, then it's time to come back and do a helium leak check. Sometimes they're called using a mass spectrometer. We call it a leak detector, but
Right.
That's a surefire way to find out exactly where any air might be getting into the furnace.
Yeah, that was kind of my next question on this, just before we get off of the topic of not being able to reach the vacuum level. Let's say it's not the gauge, let's say it's not the pump, then what are there common areas? I mean, the one that jumps to my mind is, did you check the door seal, right? That's what else, or is that valid? First off, door seals, and are there other places that we can be checking right off if in fact we're failing the leak up test, right? What are the most common places where we're going to see failure to hit the vacuum levels?
Yeah, door seals, obviously the number one issue, because that's constantly open and closed. It might dry out, needs to be constantly cleaned and greased, maybe dirt falls down in there. So yeah, that's definitely one. But also, the furnace is going through heating cycles. So stuff like the power feed throughs, they'll get hot. And so as they expand with the heat and then contract with the cold, then it creates a potential for a leak because those seals are constantly shifting a little bit. So really any penetration that goes from outside the furnace into it is a potential for a leak. But looking at what's going to see the heat, what's going to move a little bit, and like the door seal, what's been opened, or even if maintenance was done and a valve was replaced or a seal was touched, that's usually the first thing to go for.
Yeah, that was the other point I was going to mention, is the other, obviously, and this is common sense, but sometimes it's good to mention common sense. If something was replaced in the furnace, especially anything that penetrates the shell, that would probably be, and you weren't having troubles before that, obviously you want to go check that stuff out. So that's good.
Well,
okay, good. Anything? Yeah, Don, go ahead.
Yeah, further to that point, we've come up across a couple times too where a valve was replaced, and that valve was say on the gas line, incoming gas line, say nitrogen or argon, and all of a sudden we have a leak, but we can't find it. We've leak checked the entire furnace multiple times, still can't find a leak. Well, the next place to look, and it seems illogical, but the next place to look is that valve, right? Because that did change, and maybe we're okay. There's no outward appearance of any oxidation, but lo and behold, there's some nitrogen or argon leaking into the furnace through a valve seat that we didn't expect. It doesn't happen all the time, but it does happen, and that one is especially frustrating to find because it's the last place you'll ever look. So something to keep in mind.
Yeah, good point. But let's say you got a water flow alarm. What's the first thing? What are we looking for?
Yeah, I'll jump in on that one, Doug. So first, to your point, it's not just a cold wall furnace, because certainly there are, atmosphere style furnaces out there that have water cooled flanges that do require some water cooling. In any case, many of those passages that feed those flanges, or like we talked about, the power feed throughs, are very small. And all of a sudden you look down and say, oh, there's an alarm on one of the power feed throughs. It's not getting enough water. The temperature's too high. Okay, chances are good that there could have been some contamination that was somewhere in the system that's now blocking one of those small holes. And I'm talking, a ½ inch, maybe something to that effect, or a ½ inch hole. And we just don't have the flow that's expected. So the natural first step is, how long has it been since you cleaned the system? How long has it been since the system has been flushed? And it's again something you don't typically think of, don't do that often. If for some reason there has been some exposure to air in the system, or so the exposure to air will develop, typically promote the growth of bacteria, which can cause issues in the system. Or, just from natural deterioration, a lot of those systems are steel pipe and they develop some scale, and that scale goes somewhere, and the first place you'll see it is on the small passages because it blocks the passage. So there are a couple, at least that I'm aware of, biodegradable descalers available out there on the market. So, if you've got glycol, that glycol can be pumped out of the system, screened, filtered, and put back in. And at the same time, you can purchase this descaler, which typically can be mixed with city water, and you flush the system basically. And after maybe 1 or 2 flushes, you can be fairly confident you've removed a lot of that scale, and reintroduce the glycol if you need to, or reintroduce the water coolant. Important thing is that when you do that, you replace the rust inhibitor or any other chemical treatments that you think are necessary, or that you've been told are necessary from the equipment manufacturer.
Yeah. On this water cooling system, I'm curious what percent, this is maybe you might not know the answer to this, but that's okay. What percentage of vacuum furnaces out there have closed loop cooling systems, as opposed to somebody just running city water through furnace for cooling? Any sense of that?
I think the majority of our customers do have closed loop, but it also depends on how much equipment they're cooling. Because if it's a single furnace, the best scenario is usually just a closed loop small system. But when you have multiple furnaces in a room, then you're on a much larger system, takes more cooling power. And it may not be city water they're running through, but it might be an open loop system, or, just multifaceted there with their stations. So.
Yeah, I mean, I've heard it's been quite a while, and I just didn't know if it still happens, that you've got somebody that's running even a cold wall vacuum furnace, and they're running city water through it. And pretty soon, all you've got just a bunch of sludge and stuff, and you're not a cold wall anymore. You're just basically heating sludge in it.
Yep, and city water can be especially challenging because unlike having a glycol mixture with, say, DI water or DI water that you input into the system initially, that city water contains, it can be hard, so it has a lot of dissolved solids. It can have organics that can end up causing issues if there's a certain section of the vessel that doesn't get the right circulation, and all of a sudden you get a settlement of those the sediments in the water. There are lots of different challenges that are brought by the use of city water.
And heat's an activator as well, right? So as it's trying to pull that heat off, now that's kind of activating some of the stuff. That's what causes some of the scale buildup or the bacteria. So making sure the size of the system is adequate is necessary as well.
On modern day vacuum furnaces, do they have regular flow monitoring of water? I mean, are you knowing if water's going through, and can you tell over time, hey, my flow is slowing down, or can you see it coming, I guess is my question.
Yeah, so on our furnaces, we use digital indicators. Some furnaces actually show a flow rate, but the majority of them are just like a dial indicator with LEDs. And so we start with max flow, and over time those LEDs drop out and show that you're losing flow. And then when it drops below the set point, that's when you get an alarm.
Get an alarm, and then you got to do all your cleaning out.
Those are on individual circuits, so you can tell pretty much which part of the equipment needs flushed out.
Interesting. Any rule of thumb before we move on to the third one? Any rule of thumb on how frequently you think a vacuum furnace should be, descaled or flushed out? Is there, even if you're not experiencing trouble, I mean, is there hey, you should always do this every year or every 10 years somewhere?
Typically, Doug, this is it's not a 2-hour process, right? So I would recommend if you do a routine shutdown of the furnace for maintenance, be it maybe in the summertime, that's the time to do it, right? Because flushing the furnace, removing the coolant, etc., is quite an undertaking. That being said, it also depends on the type of cooling system you have. If it's truly closed loop, and it, like a lot of the systems we work with today, they actually have a nitrogen blanket, so there's very little oxygen in the system. They typically don't require flushes as frequently, but if the water that's going through the furnace can be exposed to oxygen, then we should probably think about more frequent flushes, because then you're introducing, like I say, the potential for oxidation and organic material that can cause issues.
Right. Okay, good. All right, let's move on to another, and that is another alarm station. That's over temperature. Getting too hot here. What do we do?
Yeah, so the over temperature is a big issue because that's a critical part of your process, especially when it's your control thermocouple. And thermocouples have a life and they can fail in different ways. I think the hope would be that it just the reading drops out and shuts everything down, but sometimes it shorts against the jacket. You have a small break, or it's an erratic reading, and that's can cause bigger issues because now maybe the furnace is running hotter than you think or colder, and you don't really know there's an issue. And eventually it'll kind of breach the max temperature and shut things down. But if everything's looking okay on the screen, you don't really know what's going on. So, watching your trending, make sure the temperature isn't erratic, it's pretty stable. And also measuring against your over temperature controller, because we usually use 2 thermocouples, whether it's a dual element or 2 individual ones, but you have some redundancy there, and you can compare numbers to make sure that they're within a few degrees and reading accurately.
Yeah, Dawn, anything else to add?
Yeah, moreover, I was going to say, we recommend at least, aerospace requires more frequent temperature uniformity surveys and system accuracy tests, right, to be NADCAP certified. But, if you're outside that realm and don't have that audited requirement, we recommend at least an annual temperature uniformity survey and SAT. And, there's 2 schools of thought, right? I can replace the thermocouple before it fails and just do it and say it's a sunk cost part of doing business. Or I will run it until it breaks and deal with the consequences. And it's totally up to you. Some customers do one way, others will choose the opposite. They both work. It's just you've got to be, as Caleb mentioned, watching it closely to see what it's doing. As we all know, vacuum furnaces, we can't see what's going on in the furnace, so we really have to rely on our instrumentation. If the instrumentation's lying to you, that can cause more grief.
Yeah, and whether you're replacing those thermocouples in advance, kind of to as a precautionary step, or if you're waiting, I would assume has a lot to do with the value of the product that you're running in the furnace. I mean, the higher the value, I assume you're going to say, you know what, if I miss this and mess up the product, better to replace that thermocouple on a
right. And how much are you running the furnace? If it's a 24/7 operation, obviously, if you get to the 3-month period and you're starting to see issues, maybe you just say from now on, I'm just gonna replace it every 3 months. Or like you say, if you're running 2 to 3 cycles a week because that's what you needed the furnace for, and that satisfies your production, you might get a year out of it, and it's no big deal. But you're right. If it's $1,000 thermocouple and the load in the furnace is $15,000, you've got to really consider that, right?
Right.
Another thing to check is just visual inspection, because the control thermocouples are usually just hanging out there in the air. So if you're running larger loads, it's really easy to bump it, even if you're running a survey frames full size of the working area. Right. So to make sure that it hasn't gotten bent or even the tip chipped off of it, that's a big indicator as well. And if it does get bumped, then maybe you pay extra attention or, replace it as a cautionary measure.
Yeah. Good point. Probably safe to say, don't ignore it, right?
Yep. When you
That-
get
that
over
could
temperature
be-
alarms, yeah, don't try and power through it either, so.
Yeah, that could be fairly catastrophic. You don't want to open the furnace up and have a nice pool of metal. That would not be so good.
We'll return in just a moment. Are you signed up to go to Pittsburgh this fall? From September 18 to 20th, 2023, Heat Treat Today is hosting the second Heat Treat Boot Camp, a basic training to benefit new hires and old hires who want to learn about how the North American heat treat industry works. We're talking the main players, products, processes, markets, and materials in the North American heat treat market. That is, who are the main equipment and service suppliers? What products are they selling? What are the popular heat treat processes? This is the perfect training to help you walk and talk the industry and will not be overly technical. Also, you'll have many opportunities to network in the welcoming, exciting Pittsburgh downtown venue. Go to heattreattoday.com/bootcamp to register for this training in Pittsburgh. Again, that's www.heattreattoday.com/bootcamp. Now, back to the episode.
Let's say you're having issues with the furnace software. What are some good techniques here?
Want to take that one off bat, Don?
Yeah. So, software is, as you mentioned, Doug, is a quite broad topic. And the first thing that we typically look at is it an operational, meaning is it a controller issue, or is it a display issue, right? So a lot of times we'll have a customer call and say, oh, the furnace stopped in cycle and it won't finish the cycle and I can't get it to end cycle. Well, it turns out usually when you start investigating, it's not really a software issue. Although it may appear to be, it's typically, the software is actually doing its job and there's some underlying mechanical issue that we have to go find. And again, as I mentioned earlier, we can't see in the vacuum furnace when it's running. So we have to really dig deeply sometimes to figure out what is actually happening. So I would say, I think a lot of times we tend to blame the software, but that isn't always the case. Now, that being said, let's take a step back to the display, as I mentioned. All right, they're Windows machines quite frequently, and that's a good thing because that means we can network it with the rest of our network in any facility, and it talks well. However, we all know too that Microsoft comes with its own set of frustrations at times, and those obviously aren't exempt from the display. So whether or not to update the host computer is a topic that I would highly recommend you discuss with the manufacturer, because updates can sometimes cause headaches because Microsoft is changing things in the background that aren't. Now, if you have maybe another manufacturer's computer that's not Windows based, then I would say by all means talk to that manufacturer to see. But from my experience, most are typically Windows based, and the interplay between Microsoft and the manufacturer is very important, and the manufacturer of the equipment should be telling you how to handle that process. Also, be careful. Most furnaces now have a LAN or a local area network. So all the components are communicating via Ethernet or Profinet. A lot of times customers want access to extract data from the equipment, which is fine, but make sure that you discuss how to do that with the equipment manufacturer so that we don't interfere with the addressing in that LAN, in that local network, because that will cause issues immediately. If the equipment isn't communicating within that network to each other.
Yeah.
But back to the beginning, it's always well advised to look at what the equipment's telling you, what the alarms are, what the software is telling you, and then take a step back and say, okay, what else is going on in the furnace, right? Because again, the goal is, at least as the equipment manufacturers, that we're designing the software to help diagnose. Is it always spot on? No, it's still a machine. It still can have irregularities, or we maybe just didn't think of all the scenarios, right? We do our best, but we don't always catch everything. So it's a matter of stepping back and looking at the situation. And of course, if you can't find it, that's when we or any other manufacturer can step in and say, hey, here's in this scenario, you need to go look at these items. Yeah.
Right. Good. Caleb, care to add anything?
Yeah, so like Don was touching on software glitches, but the other thing is maybe you're losing data. So it may be a hardware issue with the computer as well. A lot of these industrial PCs are pretty robust and they outlive the Windows operating system. So, to check if it's still supported by Windows or if your hard drive's full, because, we collect trend data on our computer. So there are files that will start to fill up the hard drive. And once it's out of space, then the computer doesn't know where to put stuff and can start glitching and having issues. So that's another thing to check.
Yeah. Okay, great. All right, guys, thanks. So that was the top four. Now, what I want to do now is go into the rapid fire round. All right, I'm going to give you probably 4 to 5 additional items, and just we don't want to go into a lot of depth on these, but maybe we need to. But we'll see. We'll see how quickly we can run down through these. So, first one is this: when do I know that it's time to reline and or replace my hot zone?
Yeah, so I think the quick answer would be a uniformity survey. Are you still uniform within your working area? Are you within the calibration? Or do you have hot spots and cold spots? And then another thing to check would be the energy usage for the hot zone, for the heating elements. Are you pulling more power because you're losing more heat? Because as the insulation erodes away, then the heat starts escaping that hot zone area.
Yeah. Any validity just to looking at it? I mean, this thing is terrible.
Erosion is I'd say you can see the erosion pretty quick. A lot of the seams where the insulation meets each other will start to become a crevice. Yeah. Okay, good. All right, how about, this is fairly typical. We've actually mentioned it here earlier. I'm getting discolored parts. What am I looking for?
Yeah. So discolored parts are a common complaint, right? Yeah. Hey, I was fine last week. Now all of a sudden it's coming out looks like a rainbow. Okay. Right. So typically it depends on the material being treated, right? But typically colors such as rainbow are oxidation of some sort. So now we're back to that. In the short answer, it's a leak check. Have you done a leak test lately? What is the leak up rate? Has it changed? That's the first place to start.
Yeah. I have also heard on this, and maybe you guys can comment on this, that if you're running a variety of different parts or different items, materials through your furnace, you got to be careful if the previous load might not have deposited some sort of material on a cold spot in the furnace, and then when you heat it back up again, it can react with the current load. Is there validity to that one?
Yeah, if you're running parts that have coolant or cutting oil or something, then that's stuff that off gases. And then you run a high specialty metal that needs pure air, and maybe it's a higher temperature too, so then all that's off gassing. So normally if you're running a special load like that, you should look at running a cleaning cycle beforehand to ensure that there's nothing going to off gas from previous load.
Okay, fair enough. How about, now we talked about replacing hot zone. How about door seals? Replacement of door seals.
Yeah, so the door seal, if it hasn't been greased regularly or it's old, then it'll start to crack and split. So just looking at the condition of the door seal, and then the seam, because a lot of times they're glued together at a seam. So if that seam starts splitting apart, that could introduce a leak, and it's time to get it replaced.
Yeah. So basically a mechanical inspection, unless you're getting leak up, and then obviously if you can isolate that the door seal is the issue, obviously it's got to be replaced, right? Yeah. And again, this is probably vacuum furnace 101, if even that complicated. Every time you're closing it, I assume you're wiping down the seal and the mate, right? I mean, everything's getting clean to make sure. Is that a good practice?
Yep, and you don't always have to clean it, but even just wiping it to make sure that grease didn't catch a lot of dirt in there, right, and it's still lubricating the seal. Okay.
Okay. Two more actually. One is let's say you're getting these strange black spots or black marks on the inside of the furnace, typically around heating elements and or feed throughs, things of that sort?
Yeah, so back to that, watching the power consumption, right? So some of the newer furnaces are equipped with gauges that monitor power, current, etc. If you go back and look at the trends and see a lot of current spikes, that's probably a surefire indication of arcing. And you open the furnace, see black marks. What's happening is that carbon graphite insulation is being destroyed from an electrical arc. And the next thing to look at after that are the insulators still in place? Have they been contaminated with something that is now preventing them from being a good electrical insulator? And then I guess the other thing that comes up once in a while too is what's the environment like in the furnace? Are you introducing a gas that could be creating a short, a path to ground for the heating or for the electricity that's passing through the heating elements? Those are all some things to think about.
Got it. Okay. So if you got black marks in the furnace, more than likely you're having an arc party in there when the door's closed.
Yeah, and making sure your heating elements hardware is tight because they expand with the heat, so they'll start to loosen up. You want to do periodic inspections to make sure all the hardware is still tight.
So let's say a lot of these furnaces, a lot of vacuum furnaces have high pressure gas quenching, some pretty big fans in there. Number one thing we need to be thinking about when we talk about high velocity fans and things of that sort, what are our concerns there?
Yeah, I think there are a couple different things to be aware of. Number one, when they're in operation, most of the equipment has a fail-safe to keep it from, let's say, drawing too much current for too long a time and overheating. So, we're pushing those fan motors pretty hard during quench. So, the wear during that period is very high, and over time, of course, things like bearings are going to be a concern, right? Because again, they don't always run for that long, but when they are running, they're running at, 100, 110%. So we've got to keep that in mind. Next thing is, depending on how they're cooled, that also is a consideration. Depends on the manufacturer. Some are, like still a fan cooled motor inside, so they're still relying on gas cooling. So they've got to be kept clean so that the cooling the cooling rate is correct. In our case, we're water cooling them, so we just have to maintain water flow. So we're back to that conversation. But those I think would be a couple of the key things. As I think about now, I think Caleb touched on it, and maybe he can expand, is some of the erosion that can happen in the hot zone as a result of high velocity, high pressure quench.
Yeah, as it erodes especially and creates air leaks, then that air kind of forges its path through there and makes it worse and worse. So if you start to see erosion to the point where you think air is getting through, you're going to want to try and remedy that, whether replace the insulation or even a short-term patch until you get a new hot zone. And another point.
Yeah, just real quick, Caleb, don't forget that point, the next point you're going to make, but you're talking about erosion. You're talking about actually where the high pressure gas is actually eroding let's say the graphite or whatever, so that now you're exposing the shell of the furnace or the against the
roll up for the hot zone.
Hot zone. Yeah. Okay.
Yep.
Okay. Yeah. Go ahead then.
Yeah. And then another thing you mentioned, high pressure. Well, we put a lot of pressure in there. It's a high velocity. So if you have small parts, depending on the direction of the flow, you want to make sure smaller parts are fixed nice, because if they blow off your fixturing, then they can cause damage within the hot zone. Yeah.
Yeah.
One other point to that too is that the heat exchanger, we typically don't think about the heat exchanger, but it's actually doing a lot of the work in that process. And over time, typically they're rather densely packed fins in those heat exchangers to achieve the amount of heat transfer that's required for the process, and they can get contaminated as well. So periodically, it's not a bad idea that if you're replacing a hot zone, to clean that heat exchanger.
Clean and or replace. Okay, excellent. Guys, thanks so much. I appreciate it. We will put up on the screen some contact information in case people want to contact either of these gentlemen. So, but really appreciate your expertise. Thanks very much for being with us and sharing your expert knowledge and field experience.
Thank you, Doug.
Thank you, Doug.
We hope you enjoyed listening to today's episode with Don Marteeny and Caleb Johnson. Give Heat Treat Radio a 5-star review or a like on Spotify, Apple Podcasts, SoundCloud, iHeartRadio, Podbean, or the website www.heattreattoday.com/radio. If you'd like to get in contact with Don or Caleb, go to www.secovacusa.com, or you can also just email me and I'll put you in touch. My email is bethany@heattreattoday.com. We're on the hunt for new ideas that are important to you, so if you want to hear a topic on Heat Treat Radio, let me know. Also, if you'd like to sponsor a future episode, let me know at bethany@heattreattoday.com. Heat Treat Radio would like to thank Heat Treat Bootcamp for sponsoring this episode. Sign up to network and learn tons at this basic training when you search www.heattreattoday.com/bootcamp. This and every other episode of Heat Treat Radio is the sole property of Heat Treat Today and may not be reproduced in part or in whole without advance written permission from Heat Treat Today. And I'm Bethany Leone. Thank you for listening.